Okay, so like I said, in class today, we're gonna have a four problem in this exam. In problem one, you're gonna be given scenario, and they're gonna ask you to figure out what is a sample size n, or what is a predictor, and what is the response. And of course, in problem one, they're gonna ask you to also from the scenario, how will you actually state the design matrix? How will you state design matrix X? And of course, again, I said in problem one, you also need to be able to understand how to perform a test that has to do with the regularization technique of lasso and the ridge. So, how do you use a cross validation to, to obtain the optimal values of lambda? Lambda is, you know, um, regularization parameter that we call, you know, that is that we call lambda. So penalty parameter. So that's what that is going to be centered on. So and after that, problem two, we focus on logistic regression. Okay. Problem two, we focus on logistic regression. Okay. So problem two, we focus on logistic regression, and let me tell you, logistic regression. Okay, so where you actually going to be giving the outputs. Okay, they're going to run the regression for you. Okay, and they're actually going to ask you some several questions like how do you actually um maybe there are some uh you know, you got some cell that are missing in the logistic regression output. So they wanted to figure it out. So you should be able to know, just like with the way I said in class, you'll be able to know relationship between the z value, the estimate, and the standard error. Of course, you should know that the z value equal the estimate divided by the standard error. So what if one is given and the other one is missing, and how you gonna figure it out using mathematical formula? And of course, still problem two, okay, you actually need to know how to write down a fitted model after fitting a logistic regression. So, which means that we advise that you revise what we've done on how do we present that in logic form, and how do we present that in probability form as well, and also know how to interpret, um, the estimate of coefficient associated with a particular predictor in the logistic regression. So then, and finally, under that, so you should also be able to read what I call, the deviance. Okay, how do we conduct a deviance test? Get what I mean? So how do we conduct a deviance test? Okay, you're actually gonna study all of that, so that is gonna complete problem two. Now I want to go into problem three right now. Okay, so in problem three, the problem three is actually gonna divide into two parts. Okay, problem three is gonna divide into two parts, and of course, the first part in that is going to focus on exponential family of distribution. Um, they're actually going to give you a particular probability distribution. And of course, probably they wanted to investigate whether it's from exponential family. Okay, they wanted to investigate whether it's from exponential family. Of course, what we did in class. If something follow an exponential family, you're actually gonna have you know, and you have a way to write it, f of y given uh, theta given phi, which is actually going to be equal to ESP, okay, equal to ESP, okay, parentheses, y theta minus b, okay, minus b of theta, okay, all divided by c of, oh sorry, a, all divided by a of phi, okay, so all divided by a of phi, plus c, okay, in parentheses, y comma phi. Okay, so if you're able to express the given probability distribution in that regard, then you're actually going to say it's from exponential family. And of course, using that particular information, is there a way that you can derive the mean and variance? Okay, what is the expected value of y? Okay, what is the expected value of y? And of course, what is the variance of y? Okay, now I told you the moment I know I was able to identify my b of theta, okay, the expected value of y is going to be the first derivative of the b of theta, okay, and of course, the variance is actually going to be negative of the negative of a of phi. Give me 1 second. I'm actually going to write that. So the negative of a of phi, the negative of a of phi, okay, multiply by the second derivative, of theta. Okay, so this is the formula that you actually are going to use or in figuring that out. So right now, I'm actually going to demonstrate to you how you can derive the expected value of y and the variance of y given a binomial distribution. So I'm actually going to clean up right now. Okay, so I'm actually gonna clean up right now, and I'm still on problem 3. I just want to demonstrate, I want to demonstrate how you can actually derive the mean and variance after you have investigated for exponential family. For instance, is if yi, okay, let's say y follow 1 over ni, okay, 1 over ni, uh, by norm, okay, of, for instance, of ni, okay, of ni, mu I, for instance, okay. Now, if I want to write the distribution for this right now, I'm actually gonna have the f of y giving mu I, okay, giving mu I actually going to be n combination ny, okay, n combination ny, okay, and of course mu I raised to power ny, then 1 minus mu 1 minus mu I, okay, raised to power n minus ny. Okay, so this is a scaled a scale binomial because we have 1 over, this follow that 1 over n, by norm. So when you take a look at what I actually have right now, if I want to investigate this, for exponential family. So what I'm actually going to do is I can rewrite this guy. I can find the log. Okay, I've all first find the logarithm of that, right? So the logarithm of f of y, okay, given mu I, okay, the logarithm of that actually going to be I'm gonna have log, okay, n combination ny, okay, for I'm gonna have that, then plus the ny actually gonna come down, and I'm gonna have log. I'm actually gonna have log mu I, okay. I'm gonna have log mu I, and right here, bringing that guy down, I'm actually gonna have n minus ny, okay, or n minus ny, um, log, okay, 1 minus mu I, right? So that's what I'm actually gonna have right now. Okay, so the moment I have that guy right now, so I can simplify, when I simplify, so I'm actually, if I start from here, so I got ny, okay, I got ny log mu I, right? Then that multiply, you know, what I have here is a log into 1 minus mu I. So that's gonna be plus, okay, n, okay, log, okay, and log 1 minus 1 minus mu I, right? 1 minus mu I. Okay, then I'm actually gonna have ny, okay, then I'm gonna have log, okay, into 1 minus mu I, right? 1 minus mu I, right? Then I'm gonna add this guy to that, right? So I'm gonna be log. That's gonna be log, okay, log, uh, then n combination ny, okay. I just want you to take note of that. So now, when you take a look at what I have um right now, I have ny, okay, and ny log that, okay, plus that, you take a look at, you can revisit that. I have that, okay. So when I was multiplying, okay, so this guy for that, and if I like that for that, n into n minus y, so, and okay, so I take so this one, yeah. So right now, so if you take a look at this guy, okay, that both of them are same y, right? If you take a look at this guy as well, I can combine them mathematically, right? So combining them mathematically, I'm actually gonna write ny. Then I can just write, okay, log, okay, mu divided by 1 minus mu, using the law of logarithm. Okay, you can see what I have right now. So, and that's gonna be plus, okay, n, that's gonna be n, okay, log, okay, 1 minus mu I, okay, 1 minus mu I. Don't forget, I also have mu I, right? I mean the mu squared I. Then lastly, I'm gonna have log. I'm gonna have log n combination ny. Okay, so I'm gonna have that. Now, from what I'm having now, this is the log, right? Then I'm gonna exponentiate that. Okay, so I'm gonna clean up. I'm actually going to clean up right now. So I'm going to exponentiate that. Okay. Now, I'm actually going to write f of y, okay, giving mu, okay, equal ESP, okay, equal ESP. Now, when you take a look at this guy here, I can rewrite this as, you know, if I do y log mu I divided by 1 minus mu I, okay, then here I can just do plus, okay, I can do log, okay, into 1 minus mu I, okay, and you can see there's n here, there's n here. I can rewrite everything here to be divided by 1 over n mathematically. Then here I'm actually going to say plus log, you know, n combination ny. Okay. So 1 second. Now that's what I'm gonna have now. So it is now time for me to compare with the exponential family, that to be able to know which one is the b of theta. It is only when you identify correctly the b of theta that you'll be able to figure out what your mean is. Okay, so right now I'm actually want to compare. Okay, the standard one we're gonna compare compare that guy with, okay, is y theta, okay, y theta, okay, minus the b of theta, okay, or minus the b of theta divided by a of phi, okay, a of phi, okay, plus c, okay, plus c into um y comma phi, okay. So what you can actually see right now, the theta is actually going to be log, is going to be log mu 1 minus mu, and what is your b of theta going to be equal to? So the b of theta now is actually going to be negative, okay, of that guy, log 1 minus mu, okay. Now if this guy equal to that, so from here, okay, you have theta to be mu log mu over that. You can solve for mu here to be able to get that in terms of theta. So which means I'm actually gonna have e raised to power theta equal mu over 1 minus mu. Okay. Now if you want to solve for mu right now, okay, so where you introduce this guy divided by 1, you're actually gonna have 1 minus mu, okay, e of theta, okay, equal mu, okay. By the time you are done solving for mu, you actually are going to obtain e raised to power theta, okay, divided by 1 plus e raised to power theta. That is exactly what you're going to get. Now, if mu, okay, equal to e raised to power theta divided by 1 plus e raised to power theta, okay, now, well, don't forget, what you're actually looking for is you want to get a function of, you want to see what you're going to plug in here. Okay, right now, this is what mu is equal. So if mu equal to what I have here, what is going to be 1 minus mu? Okay, in a way. Okay, so what's going to be 1 minus mu? Gonna figure it out now. So 1 minus mu, okay? You know, mu is this guy. So what is 1 minus mu? So I'm gonna do 1 minus e raised to power theta, okay, divided by 1 plus e raised to power theta, okay. So by the time you probably simplify that guy right now. So I'm actually gonna have that e raised to power theta here, and of course you're actually gonna have 1 plus e raised to power theta, okay, minus e raised to power theta. So what does that mean? Which is actually giving you 1 divided by 1 plus exponential raised to power theta. And if I want to write that mathematically, I'm actually gonna say 1 minus mu I. Okay, 1 minus mu I is actually, I can write that as 1 plus e raised to power theta. Okay, everything raised to power negative 1. Okay, everything here raised to power negative 1. Okay, now this is my 1 minus mu I, and of course, that is my mu I, right? Now I will come back here, I want to get my b of theta, right? Minus log. Okay, then what is 1 minus mu? I just figure out the 1 minus mu to be that. So I'm actually gonna clean up right now. Okay, so clean up. I'm gonna clean up. So what do I have right now? So I got b of theta. Okay, the b of theta now is gonna be the b of theta is going to be negative log, okay, what is 1 minus mu in terms of theta is what we have right here. Okay, so which is 1 plus e raised to power theta, okay, 1 plus e raised to power theta raised to power negative 1. So I can rewrite this guy as negative, uh, you know. So if I have, so which can be written, I can write that as negative 1 over 1 plus e raised to power theta. Okay, so this is what I'm going to differentiate. Okay, that's what I'm actually going to differentiate. Okay, and of course, I'm going to differentiate that, like I said. I want to get I'm going to say the b prime of theta because I want to get a certain value of y. Okay, and so I'm actually want to differentiate right now. And in fact, before the differentiation, I think I should be able to rewrite this as when you see a negative here and that's a log here, the negative here can multiply the 1 here so that we can have just log 1 plus e raised to power theta. Okay, so right now, if I want to differentiate that, okay, in differentiating that, okay, it's going to be differentiating that is going to be e raised to power theta, okay, divided by 1 plus e raised to power theta. So which actually mean the derivative of that is this guy, and that guy is actually mu. If you take a look at this guy, right? That's actually going to be mu. Okay, so which mean the expected value of y It's good. It's this mu. So mu here is the proportion. Okay. And how am I gonna find the variance? Okay. I'm also gonna show you how you get how you're gonna get the variance as well. Okay, so don't forget, I said if you want to get the variance of y, right? If you want to get the variance of y, okay, it has to be negative a phi, okay, negative of a phi, the b prime of theta, okay, and of course the other time. I identify my A phi to be 1 over n. So I'm going to write 1 over n. Okay. Then I want to differentiate this guy now. Okay. So differentiating this guy, you can actually use, the quotient rule of the differentiation. Okay. Where I'm actually going to write, 1 plus, e raised to power theta. Okay. Okay, then I'm going to differentiate. So you write this, differentiate this one. Okay, so then I'm going to write e raised to power theta. Okay, minus. Okay, so minus. Then you write this and differentiate that. So you write that. Okay, and differentiate this guy here. It's going to be e raised to power theta. And what I'm going to do is to divide by the square of that. So I'm actually using quotient rule of differentiation, navigating that. Okay. Now, what am I getting right now? So what I'm actually getting right now is that then I'm actually multiplying out. Okay. So right now, so I'm gonna clean my whiteboard. Okay, so getting here now. Don't forget, I'm actually talking about the variance of y equal, okay, so negative uh 1 over n. So e raised to power theta, so trying to multiply now, plus so that guy is e raised to power theta raised to power 2. Okay. So e raised to power theta times e raised to power theta. So that's what I have, raised to power 2. Then minus e raised to power theta. Okay, minus e raised to power theta. Or raised to power 2. Okay, now divided by 1 plus e raised to power theta. Okay, all squared. Okay, so this guy cancel out that guy. Okay, now if that guy cancel out, so the next thing that I'm actually gonna do is negative 1 over n. Then I have e raised to power theta, okay, divided by 1 plus e raised to power theta squared, okay, squared. Now minus 1 over n. Now, from here, okay, from here, I can actually get this guy out. E raised to power theta, okay, divided by 1 plus e raised to power theta, okay, and, I can break it down into 1 over 1 plus e raised to power theta, okay, because of the squared that you see here. So, and what is this guy? Okay, e raised to power theta divided by that. That is going to be mu, right? So it's going to be mu. Okay, and here, okay, this is 1 minus mu that I showed you the other time. So if I wanted to write that now, okay, that's a negative 1 minus mu. Okay, and the negative is going to cancel the negative out. So what am I going to have finally? I'm going to have 1 over n, okay, mu into 1 minus mu. Okay, so this is the variance now of the binomial that I talk about. Okay, so which means, like I said, in problem 3, you're going to be given a distribution where they're going to ask you to show that follow an exponential family. After you've done that, after you've done with that, then you're going to need to differentiate the b of theta for you to be able to get the expected value of y for the distribution. Then you're also going to perform a second derivative on the b of theta, multiplied by a of phi, to be able to get the variance. So the and so for problem 3, like I mentioned, you're gonna have something like that, and of course, know how to derive the deviance of a given probability distribution, and how do you derive the expression for the residual deviance. And finally, problem 4, we centered on Poisson regression. Okay, I'm gonna say that again. Problem 4, we centered on Poisson regression. Okay, problem 4 have 2 parts. Okay, now you need to understand how to write a feeder model with Poisson regression, and how do you actually show that how do you investigate over expansion in Poisson regression. Okay, so like I said, problem 4 we focus on Poisson regression. Okay, like I said, problem 4 focus on Poisson regression. Okay, know how you can write a fitted model with a Poisson regression. How can you interpret with a Poisson regression? And how do you actually investigate for over expansion in Poisson regression? And how do you conduct a deviance test with Poisson regression? Okay, and of course, the other parts of problem 4, we focus on what I show you the other time. Okay, so that is that. That's how. So we show our very best of luck. Our advisor, you just check our announcement section where I'm actually going to post areas this exam will cover. Bye for now.